Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on determination of viscosity by capillary tube method. So in our last lecture, already we have discussed the theory and theory part and the derivation of capillary tube method. So how to identify the coefficient of viscosity by this. So based on that concept and that formula, we are going to solve a problem on that. So here I have taken a question of the viscosity of an oil of specific gravity 0.9 and which is measured by capillary tube method. Of a diameter is given 50 millimeter. The difference of pressure head between the 2 points is 2 meter apart is 0.5 meter of water. Okay. The mass of oil collected in a measuring tank is 60 kg in 100 seconds. And find the viscosity of oil. So this is a basic simple question is given. Just we need to identify what are the data are given in the question and what is the formula to calculate the viscosity of oil. And if you remember that concept of determination of viscosity and what is the main schematic diagram of that, like how the oil will be or how the fluid will be coming from that tank and how it will be flows through a pipe, then how it will be measured in a measuring tank. So then it is very easy to solve it. So let me write down the data given. So data given here, if you take the specific gravity of oil is given 0.9 and next is the diameter of the capillary tube. So diameter we can write 50 millimeter is given. So this one we can just convert into meter, it will be better. So this one we can write 0.05 meter. And next is the difference of pressure head between the 2 points, that is nothing but length. So this is nothing but length is 2 meter from each other and 0.5 meter of water. So that is nothing but this is H actually. That means the pressure head, the difference of pressure head between the 2 points, the 2 point gap is 2 meter and this pressure head is nothing but 0.5 meter. So that is H 0.5. And next is the mass of oil is collected in a measured tank is 60 kg in 100 seconds. So mass of oil is given, that is 60 kg and time period is given T. How much is given? This is 100 seconds. So yeah, before going to solve it, let me show you what is the concept of this. Actually there will be a tank here and in this tank at least some kind of fluid will be present in this and here one tube will be there and this is another flowing tube will be there and from suppose this is the tank is there. In this tank actually the oil is present or the fluid is present in this tank. So from this tank the oil will be flows in this tube. By the meantime we have a capillary tube is there. Through in this actually this is the pressure head will be there. So this is the height of this in the tube so that we can get the pressure at this point. So this is the height of this and this height is nothing but 0.5 meter. 0.5 meter. And now yeah, the distance, suppose the fluid which is flowing through this pipe, okay, is coming out from this. See, the mass of oil is collected, so that means the fluid which is coming out, the fluid means the oil which is coming out or that is flowing through this pipe will be collected in a tank. So like how it is collected with 100 second time, 60 kg of oil was collected in this. So from here we can find out the quantity actually. So or you can say the discharge we can identify from there. So this is the concept actually. So, and the distance of this, from here to here, this distance is nothing but that is 2 meter. This is 2 meter, the length. Okay. Yeah. So next, let's find out what we need to calculate, the viscosity. So as per our formula, we know that viscosity mu equal to, we got in the last class, this is the formula, pi rho g h and d to the power 4 divided by 128, 128 some formula there along with the 128. Yeah, discharge is there, and the length of the pipe, you can say this is the. So here if you see, rho is we need to see g value, we know, h is given, d also given, q value need to be identified, l also given. So few things we need to just identify. So first one, the rho we can say the density of oil. So density of oil, specific gravity is given. So density of oil is nothing but, we can write rho of oil equal to 0.9 into 1000, we can multiply, so that we can get density. That means 900 kg per meter cube. And next is, we need to find out the discharge. See, these data given, so only two unknowns are there, this one and this one. So one already have found here. Next is q is nothing but the discharge. So q equal to, we can write the mass of oil per second, mass of oil per second divided by rho. Okay, so this one also we can write. Now mass of oil is how much? Mass of oil is 60 kg per second. Per second is 100 seconds. So we can write, this is 60 divided by 100, so nothing but 0.6 divided by rho. So rho is here how much? 900. Rho is 900. So this is actually the discharge. So this much meter cube per second we can write. Okay. See, the mass of oil kg per second is there, and here it is kg per meter cube. Okay. This one, if you write here, mass of oil kg per second, and here it is kg per meter cube. So meter cube will go up, kg to kg will be cancelled, so meter cube by second. So this is the unit of this discharge. And now what we'll do, we'll just put these values in this equation. So we'll get the value finally. This is pi into rho is there, that is nothing but 900 into, this is g 9.81 and h value 0.05. Yeah, 0. No, h value is 0.5, sorry, 0.5 is this one, the diameter is there, so we can write, okay, 0.05 already written, so to the power 4 I can write, and this is nothing but 0.5 I can mention here. Okay, and divided by 128 into q is nothing but 0.6 divided by 900 into L, length is 2 meter. So if you solve this one, you can just get the value of viscosity here. So let's solve it. So one by one we can write, like, pi into 900 into 9.81 into 0.5. Yeah, let's see, multiply. Yeah, we can do one thing, 0.05 to the power 4. Yeah, so 0.086, suppose 0.086 into, we can do one thing, 978 into 900, so this will come 78, and divided by, it is already there, one more term is there, So we'll do one thing, divided by bracket start 128 into 0.8, sorry, 0.6 into 2. Finally, we are getting 0.5. Here 120, 0.6, and this is 2. Some value will be there here, and finally we are getting 0.507. So this is 0.507, and this one we can write, Newton second per meter square. And if you want to convert it into poise also, you can convert it. Just you multiply with 10 so that we can get it in terms of poise. That is nothing but 5.07 poise. So I hope you understand how to solve the problem. First of all, we need to know the formula of viscosity, what we have derived during our capillary tube method. So because the problem belongs to capillary tube method, so how you can identify that problem which belongs to which method? So in the question itself, definitely it will be mentioned here. And once you identify the problem belongs to this method or some other method, then based on that we can we can remember, or you can just recollect our formula, what we have defined there or what we have derived there. And after that we can find out the data given from this question. So based on the data, we just write down all this value one by one, and then like what are the requirements are there in this formula, like what are the data are given here and what are the data are missing. That means we need to identify. Suppose here all the data are given except this rho value and the q value. So what I did, rho just I have calculated from this specific gravity given. Just you multiply with the specific density of the standard liquid, that is water, so that is 1000. So we got the specific density of the oil. And next is the discharge. The discharge, we know that mass of oil per second with respect to rho, we can identify this. So once you calculate the rho q value discharge, then we just put all this value rho q and all this value in this mu equation, and this is our final answer. So I hope you understand how to solve the problem related to this capillary tube method. If you are having any kind of query and doubt regarding this, you can give a comment in the comment box. Thank you all.